Hi, welcome to the first in a series of video lectures that will accompany this course. In this video we will discuss getting started with the Jupyter notebook, and that's pretty much what you're seeing here, and we'll go over two of these notebooks. For each lesson we will have a separate notebook. I have decided that instead of using Anaconda's Spider, we will use Jupyter. I find that Jupyter is much more suitable for the context in which we will be working. The Jupyter notebook allows for mixing of instructions and code in a much more modular fashion, and this I find more suitable for the instructional environment in which we find ourselves. Jupyter should be accessible from your Anaconda installment. So if you have Anaconda installed, normally it shows up right here. You just click it, or if it's not showing here, you come down here, look for Anaconda. Most machines are 64-bit machines now, so you come down here and you click Jupyter Notebook. If you need to install Jupyter on your computer, simply navigate to the Anaconda website, so you can just Google for that, and you're here, and then you just come down here and get the distribution you need, and then you can download for Windows, Mac, and Linux. So from this point on, you should be able to do this if you need to. So you download and install Anaconda, and it'll come with Jupyter, and you'll simply be able to come and maybe you'll see Jupyter here, or like I said, you come down here and look for it in here. So I won't go over the installment process with you. It is a fairly simple process, and there are dozens of videos on YouTube that show you how to do this. So let's continue by downloading the first file we'll be using. In this case, it's a zipped folder. So that's going to be this one here. We download the folder, and I recommend that you download this to your documents folder. So I'll click on this. Now some computers, on some computers the download is going to be automatic, so you need to know where to find it. So I don't want it in the F drive, so I'll just come here and click Documents. So make sure it's in My Documents if you're using Windows. If you're using Windows, put it in the My Documents. Okay, so now I have that there. So let's navigate over to My Documents, which is already here, and I go and look for this, and then I have to unzip it. So this is Windows 7 that I'm using, so it may be different. So for me, all I have to do is click Extract All, and it says where I want to, put it. I'll put it right here, and here it is. For some reason, when we unzip, we get a folder inside of a folder. No problem. We just drill down until we see it here. So that's good. So let's go back now to refresh this page, and we go over to Documents, and that folder should be in here somewhere. You see it here, and we click on it and go inside, click again. If you don't like that, you can maybe fix this up somehow, so I leave that to you, if you have your preferences. So we're here, and now we click on this. So why did I have to use this folder here? I won't always be giving you a zip folder, but for this worksheet I have some images, and for you to see the images you have to have the picture files right in the same folder in which you have the Jupyter notebook. So this is a Jupyter notebook. Notice it ends with IPython. So IP stands for IPY stands for IPython. So before there was Jupyter, there was IPython. And so this is really an IPython notebook, and they haven't gotten around to changing the name of this extension here. So we click on this, and we have our first worksheet. So this is what we'll be working on. So here we have our first notebook. Notice it is actually a web page that runs in your browser. So let's go over this notebook. The first thing you might notice are these cells. There are essentially three types of cells. There are cells called markdown cells, and I use these to communicate like instructions and create headings and stuff like that. So here, this is a markdown cell also, and these are cells for code. So notice up here you see it. When I click in here, you see code. When I click here, you see markdown. There is also a third type of cell, and that's called the output cell. And so when you run your code, the output shows up in that output cell, and you'll see that right now. So let's start looking at this. The first thing you need to be aware of is that any line that you type up, so this is a code cell, notice, any line that you type starting with the hashtag or the pound sign is considered a comment. Now, a comment is simply information that you place in your code to explain to yourself and to others just what's going on with the code. It helps with understanding the code. When the program is run, lines like these get ignored. The computer doesn't do anything with them. These are strictly for you to read. So how does the computer know that it should ignore it? Well, a line that starts with the hashtag gets ignored. Sometimes you have code that you don't want to erase, but you just don't want it to run. Well, what you can do is surround it with these hashtag signs, and then that code won't run. So more on that later. So this is a code, and how do you run code? You just hold shift and click and press enter. Now if I do that here, you don't see anything happen because, well, these are all comments. So there's nothing for the computer to do. However, here we show how to use a print statement. So I expect you to go over this much more slowly than I am doing this. I'm just trying to show you how we do this here. So this is one way we can use the print statement. Now, there are new recommendations for how to use print statements, and we look at those later on. But I'm quite sure for the foreseeable future, many people writing Python will use print statements, as we're going to show in this worksheet here. So now I typed up these. So now these are instructions that will run. If you hold shift and press enter, you see the output here, right? So strictly speaking, the output is not a separate cell. It forms part of the code cell. So now you're supposed to do this. So here's an instruction. Notice this is a markdown cell, and this is a picture, and I put a picture so you don't just copy and paste it. And wherever you see this statement, well, you type your instructions in here and run. So let's do one. print, then open, then I love programming. Hold shift and press enter, and there it is. And so you need to do the rest. And so you should be able to do this also. Type these out and print them. So this is what I was saying. This is kind of like I shouldn't say old, but there's a new way to do this. But I'm sure this will be around for a while. When new recommendations come out, it's not like everybody jumps on board, and people have their way of doing things and are reluctant to change. And I guess that's why I wrote this way. So make sure you understand this, right? So practice this and see what you get. So let me just do one for you. Print, and here I'm printing the literal 5. Hold shift, press enter, and there we go. So then we come down to variables. So a variable is just a location where you can store information. And here are some rules for naming variables. So make sure you read this. You can pause this video, or you have the worksheet open. You make sure you read it carefully. So here is some code showing you how we can use variables. Now in this example, I have some very meaningless names for the variables. So this variable I call X, this one I call Y, and this one I call Z. However, when you write code, you will know what your program is all about. You should write meaningful variables, meaningful variable names. So let's run this. So you don't see anything happen because there is no output. You just assigned 5 to this variable. So once you do something like this, the variable is created and given a value. So you can't separate the two. You can't just create a variable without giving it a value. So let's show that at this point now. Let's change this from X to, let's say, P. If I do shift enter, notice we get a problem. So this is Python's way of telling you, hey, I don't know what the heck you want me to do. I don't know what P is. So if I type X now, because I have already declared it and assigned it a value here, if I go shift enter, notice it tells me what the type is. X is an integer. So we'll be working with 3 types of variables for the most part in this course. Integers, floats, and so this is a float, 1.23, and strings. Later on when we get into objects, you'll see that the variables can be many different things, and there are many different types. So notice we get a different answer when we run print type X. We're given that it's of the class int. Later on when we do object-oriented programming, we will understand what class is. So here you're supposed to find out what the type of the other variables are, the type of Y and the type of Z. So I'll leave that for you to do. We come here and we see that we can print a more sophisticated sentence saying that the variable X is of type and has a value, so we can print out the type and the value. Again, this is the old way of doing it. I didn't want to get into the new way at this point. In the next video we will, or I should say the next worksheet. So if I do that, we see that the variable x is of type, and then I output what the type is, class int, and has a value of, and I output the value 5. So notice from this point on, if I just type x, the system understands that I want the value that's stored there. So you're supposed to do the same thing here now for y and z. So practice this. Here we look at basic input, and to get input from the user we use the function input, and we also put a string. Now there are other ways to do this. You don't have to put a string, as we'll see later on. So if we run this, well, let's run it and see what happens. You're asked for your name, so I can type my name here and then just click enter, not shift enter this time. So when this little code snippet runs, the first thing it does is executes this and asks you for your name. When you supply your name, it places that name in the location fname. This is a variable fname, so what you enter is associated with this variable fname. And so from this point on, I can print what you entered by saying, in this case, hello, and then fname. So notice when you type the name of the variable, you get the contents, and so you can type something else. So let's run this again. Shift enter, and I can type John, and notice it says hello John. So here you're supposed to use this information to carry out this task. So read this and do it. You also need to be familiar with math operators, so make sure you know these. These should be familiar to you. The only one that might seem a bit strange is the modulus. So the modulus gives you the remainder of a division, and this might be new to you also. This is floor division. So if I divide, say, 5 by 2, but divide it this way, I get 2, not 2.5. So make sure you read this carefully. This is to raise to a power. So Excel uses the little carré sign, but here we use 2 asterisks. So 5 to the second power or 5 to the third power is 5 asterisk 3. You can practice those in here. So let's look at that. So if I want to go 6 to the third power, I can do that like that. Notice. If I want to go 19 divided by 2, I get 9.5. But if I use the floor operator, and you'll see later on why this can be useful, I just get 9. And of course, if I use the modulus, 19 divided by 2, well, you get the remainder 1. So sometimes when you do division, you want to get the quotient and the remainder. So 19 divided by 2, like this, gives you the quotient 9, and then if you want the remainder, you just do that and you get 1. So study this code and run it. Now very often when you're writing code, you don't reinvent the wheel. There's a lot of code that's already written there. And so essentially what this import statement is doing is allowing you access to code that has already been written. So for example, if I want to have the constant pi, well, pi is already established, and so I can just import math and then say math.pi. So with math.pi, I get access to that value. So again, read this carefully and run this code. So it asks for my name, let's say Rick, and then asks for the radius of a circle. I want to calculate the radius of a circle. Let's say it's 4 units, and it gives me the length of the circumference. So you have some tasks here to do. Think about how you're going to do it, and then write the corresponding code. So here we look at Booleans. So Boolean values are just 2 types. They're false and true. So run this code, and you see if I say x equal true, so this is a Boolean object true, and this is another Boolean object false. When I print x, I get the value of it, which is true, and if I print the type, I get that it's of the type bool, which means it's of the Boolean type. So relational operators, which are also called comparison operators, return true or false. They don't return like a normal value. So for example, an operator like plus, 3 plus 2 gives us 5, but 3 greater than 2 doesn't return a number, it returns true, and 3 greater than 11 returns false. So we use these operators in that way. So here we have, for example, a is equal to 5, b is equal to 9. We run that, nothing happens. But now when I say a greater than b, well, watch that return, 5 greater than 9. Remember, when you say A greater than B, the system looks for what value is associated with A and for what value is associated with B, and then carries on. So here we get false, obviously. If I run A less than B, I get true. If I run A equal B, but now notice it's not a single equal sign, it's two equal signs. If you say A equal B, what you will be doing is assigning the value of B to A. So you get false because A is not equal to B. And of course, if I say this means not equal to, A is not equal to B, true. And then I can change values. And so practice these and make sure you understand. So look at this one here. I make x 10, y 12, and I have all these print statements. X greater than y is, and then I put x greater than y. And that's going to be false, obviously, because x is less than y. So if I do this, you see x greater than y is false, x less than y is true, and so on. So change these values and play with this so that you have a good sense of what's going on here. And then your final task here is to write a script that converts temperatures in Celsius to temperatures in Fahrenheit. So you can read this and do this. Okay, so that's it for this video.